Hi, my name's Cooper, and today I'm going to be sharing a brief tutorial for the IME 331 Thor Hammer Simulation SOLIDCast 9. Before we start, I want to say this is not a substitute for the original video made for SOLIDCast 8, so please consider this as supplementary, and make sure to watch the other video for more detailed information. I'm mainly going to show where to find all the settings in the new version, and point out some ideas that I came across when working on this project. So to start, we're going to make a new model. You can call it whatever you want. I have it here as SolidCast example Thor's hammer. Click on the right arrow, and that will start up SolidCast Model Builder. Now, right when you enter the SolidCast environment, make sure you have metric selected for your unit system. Now, this might be confusing, especially if you've made a part for like a different project that's not this in SolidWorks and you're using like inches. Make sure you still choose metric because I tried it out and the conversion does not work when you choose inches and try to import your model that was made in inches. So just keep that in mind. You can change it back after you import your STL files. Anyways, to start, we're going to click Add Shape here on the left, and we're going to import the Thor Hammer STL file. So make sure for the added shape you have your selected STL file. We're going to keep priority as 5, we'll get to that in a second. Make sure the material is casting, and then for the STL file, select your Thor's hammer, and click Add. So now you've added it to the environment, so I find the easiest way to navigate around here is to click on this cube in the bottom right, and then click on the XZ plane, which is like your forwards orientation. If you see here, you see like forwards, right, backwards, etc. And now we have the Thor hammer head in the environment. So really quick, we want to reorient it to be in the correct direction that we're going to be casting it in. So we're going to select it by going to this square tool here, select visible by pick, and click on it until it turns red. And I'm going to go to rotate, and we want to rotate it 90 degrees about the X. If you don't know which way to rotate it, you can use these and try rotate it until you find like which direction is correct. I just happen to know that's 90 degrees about the X and then 270 about the Y. And press OK. So now that we have this in the right orientation, we can move on and import the gating system. So we're going to add another shape now, another STL file. But this time we're going to set the priority to 6. And instead of casting, we're going to use a riser material. So what this priority of 6 means is that the higher number indicates which material will be ignored if there's overlap between your two models. So in case your riser gating material does not perfectly match up to your part, then this will, like, for any conflicts, it will instead choose to keep the part instead if you have the riser as a higher number priority. So we're going to select the file for our gating and click Add. So now we have the gating here in the environment, and once again we want to rotate this, and we're going to align it so that the two gates are aligned with this curved part of the hammerhead. So we're going to go back to the select tool, click on the gating, and we're going to start by rotating it. So this one we're just going to rotate 90 degrees about the X, like this. You can just type in the number there. Press OK. Now it's in the right orientation, we just need to move it over. So you can click on Move. And then in the video for SolidCast 8, there was a way to use pick points to simply lock the gating over onto the part. But I haven't been able to find that feature in SolidCast 9. But it does have these helpful arrows here that you're able to drag and just move the part in place. So I'm using middle mouse button to drag around the part. And from here, you can just make sure in all the orientations, it looks like you're moving it so that it lines up. It overlaps a little bit with the part. on all sections of the gating. So try to center it as best as you can. Go a little more in. I think that looks pretty good. Press OK, and we can orient ourselves here. And that looks about right. So now that we have our STL files out of the way, we can turn off metric. That's going to be nice. When you click around here, you'll see like the scale of all the parts is in inches, and that'll just maybe make more sense. It doesn't really affect a whole lot until we get to this next part. So next we're going to add the fill material, which we're going to do by adding a shape once again. We're going to add a cylinder. We're going to go back to priority 5, and we're going to add the fill. So the fill material is where the simulation is going to pour the material into the casting. So we want a cylinder, priority 5. We're going to do fill material. Don't worry about what metal it chose here. I probably have a different one set than you do. And we're going to make the radius and the length both 1/2 inch. Now it's going to be helpful to have it as inches. Otherwise, we're going to end up with a very small cylinder. As for the location, instead of typing in these numbers, you can just click right here in the center of the top of the gating, and it will automatically just update those numbers for you. And you can click add. And in case you've added it in and it's not quite in the right place, you can once again go into the move tool and drag it around as you want. Sorry, you're going to want to select it first. And then you can move it around as needed. Once you end up here, you're done importing all of your shapes, and next it's time to start working on the mesh properties. So the mesh is what the simulation uses to calculate the metal flow. It's going to include most of the properties, such as like what materials you're using. So to start, we're going to go to the materials tab here on the right, and whatever you have here for your casting metal, we're going to click replace. And here's the list of all the alloys. And then for this example, we're going to use a 17.4 steel. You can type in 17.4, or you can scroll down and find it yourself. And click OK. And that'll update it for the casting, the riser, and the fill. Additionally, we're going to be using investment shell, not silica sand. So to do that, we're going to click add. And then you can scroll down to investment shell. Click OK. And then I just found it useful. You can just remove silicon sand because you're not going to need it. So now we can go to the molds tab here at the top. And then you can click investment shell. And we're going to set this initial temperature to 1600 degrees Fahrenheit, meaning that this would be like a heated mold before the metal's being poured. Next, I'm going to move over one to the Foundry tab, and we're going to make sure the fill time is set to 3 seconds, and the temperature is set to 70 degrees Fahrenheit. This is like the ambient temperature mentioned in the video. And then we're going to move over to the Mesh tab, and we'll make sure our material is set to investment shell. And then make sure open top is selected, and then the mold thickness is 1/2 inch. So here you can determine the number of nodes that are going to be used in your simulation. In the video, both 1 million and 100,000 are used, but for the sake of time, I'm just going to use 100,000. You can come back and run your simulation with more nodes after the fact. Once these properties are all set, you can click Create Mesh. And click OK. And every time you edit any of the mesh properties, you're going to want to rebuild your mesh from scratch. And that's what will cause your updates to take effect. So there we just saw it calculate the areas and build the shell. And unlike in the video where Cole he shows off the mesh tree, I wasn't able to find any of those features, so I just ran the meshes separately. So you can come back to this later and then replace this with 1 million and then create a mesh again. And next we can move on to the simulation. So click on the simulation tab. Make sure the stop condition is 100% solid casting and riser, and then click use flowcast. And then you can start flowcast. So here you have the flowcast window up, and by clicking on this double arrow right here, this will start the simulation. So because I'm using 100,000 nodes, it takes a little bit of time, but it's not terribly slow. Once you're using 1 million nodes, this is going to take much longer for it to calculate the interactions between all of the nodes. But here you can do a few interesting things where you can change what property is being displayed by color. So instead of looking at the temperature, you can instead look at like the velocity of the metal, or you can look at the pressure, or any of these other properties, and leave it back as temperature. You can also look at several different views, such as from the negative y direction, positive z direction, and all of these views here. We're just going to let this run. It's only going to run up to 3 seconds since we set the pour time to be 3 seconds. And you can see how it changes over time. Now we're skipping forward, and you can see that it's almost done filling. So once we reach 3 seconds, we'll get this pop up. It'll tell us what percent is pure liquid, and what percent is fully solidified. You can click OK, and then you can close out of this window. And then next, you can click Run Simulation, and press OK. So here you have the simulation window. Now, I have a lot of issues with SOLIDCast crashing here when I'm trying to change the properties, but feel free to refer to the other video for SOLIDCast 8 here, as it's essentially the same thing. You can skip to about 16 minutes into the video for that. But here we can look at the results viewer, if you want to access that. I believe this is done in the video. Once you're done, you can close out of it. And then for exporting the video, you can click View Flowcast Results, and then click on the Animation tab here on the right, and then scroll down and click Create Animation File. Before you do that, you can set what temperature and what view you want the simulation to be in. So we can change it to like before, and then we can maybe look at pressure instead. And then we'll click Create Animation File, and then just save it, and then it will run at real time based on the data it's already saved. Hope this helps. I definitely spent a lot of time just trying to figure out where all the settings were, so hopefully this took you less than a few hours. Thanks for watching.